Hi, and welcome to number 4, the last of our 4 constant velocity challenge questions. Here we find ourselves in the middle of a cross-country race with a Nelson Mack collegiate cross-country runner in second place. The leader is 74 meters from the finish line, and the Nelson Mack runner is 92 meters from the finish line, so he's behind. The leader is running at a constant velocity of 3.8 meters per second. So the question is, with what velocity will the NMC, the Nelson Mack runner, have to run in order to win the race by a margin of 2 meters? Not just win, but win by 2 meters. So it starts off by saying we should sketch a position versus time graph to show the runners. Now I drew my chart here, my graph, a little bit different than normal because, and I think you'll see why, all of the measurements of position here are based from the finish line. So I'm going to say that my origin here is my finish line. So the Nelson Mack runner, it starts off at 92 meters from the finish line, before the finish line. So they're actually going to be at negative 92, and that will be our Nelson Mack runner. The leader is at minus 74. This isn't to scale, this is just to help us think a little bit. That's where the leader starts from, and the Nelson Mack needs to win by 2 meters. So I'll put over, I'll just move this out of the way, has to win by 2 meters. So this is position. So let's think about the Nelson Mack runner first. So the Nelson Mack runner, and let's say that this is the time to finish the race. We'll be right there. So the Nelson Mack runner has to go from 92 over here to the finish over there. Okay, so that is the Nelson Mack, the NMC runner. Now the guy who is currently the leader is going to be starting at negative 74, and by the time the Nelson Mack guy is done, in fact I'll just move this out of the way, he will be not at the finish line but at 2, so he'll be over there. So I need to draw that line. Okay, so this was the quote-unquote leader, starts off as the leader, that's why I'm putting the quotation marks, and in blue over here, that's the NMC runner. Okay, so, well, what else do we know? Well, we know that, if we put over here, I'll use my A and my B here. So maybe I'll use the NMC runner will be A. So let's see all the stuff that we know. So the velocity for A, well, that's what we need to find out. So I'm going to put the question mark there. What is the change in position from of the lines that we drew right now? Well, it looks like we're going to go from negative 92 up to 0, so this will be actually a positive 92 meters. And our time, we don't know yet. So let's go look at the leader over here, the guy who starts off as the leader. So this one, we know what the velocity is because we're told it's 3.8 meters per second. What's the change in position from now until the end of the race? Careful, it's not minus 74 because they end up at negative 2. So it's actually going to be 72 meters. So now to figure out time, well, if velocity is equal to delta x over delta t, with a little bit of mathematics, I can say that this is going to be the position, or the displacement, pardon me, divided by the velocity. So I will get, 72 divided by 3.8. This is a good time to use the memory in your calculator because I get a really ugly number here. I get 18.947 seconds. I'm going to just say over here, use memory in your calculator at this point because we don't want to round off yet. So I know there's more digits, so I'm just going to write the first 3. So now we're going to go over to the A side over here. I'm going to say, well, that is actually the same amount of time as over here that the Nelson Mack guy is going to be running. So the Nelson Mack velocity is going to be equal to 92 meters divided by that 18.947 6.947 seconds. So when I do that kind of a calculation, what do I get? I get 4.85 repeating meters per second. So I think I've got part one of my answer, right? With what velocity will the Nelson-Mack runner have to run in order to win? So we'll have to go at 4.85 repeating meters per second. But there is a second question, which is, at what time will will he overtake the other runner? Oh, well, if I look at this, again, it's not to scale. This is that time. So this is the time that we need to figure it out. Okay, so this is sort of like our other kind of questions. We're going to say, well, we have for A, a mathematical model. We found out that the Nelson-Mack runner is going at 4.85 repeating meters per second. And so I'll say times time, and they started at minus 92. The leader, the guy who was the leader anyways, up until the time that we're figuring out, they were going 3.8 meters per second times the time minus 74. So at this point it's getting kind of familiar. We're going to equate those two, and so when we do our math we'll get 4.85 repeating time minus 92 equals 3.8 times the time minus 74. I'll subtract 3.8t from both sides, so I get something like 0.95 repeating time equals 18, and then my time ends up being 17.05 seconds. And there's my answer. So you'll see, yeah, this time was almost 19 seconds. So here, about 2 seconds previous is when they overtake. All right, I hope that helped you out. Thanks.